Studying the Earth's core is quite a challenge. In fact, we say that the Earth's core is an inaccessible place, truly inaccessible. Directly, we can't study the Earth's core. It's impossible. Unless in some movie where people build a spacecraft and journey to the planet's core. However, that's more fiction. How do we study the Earth's core in reality? Through seismic waves, waves generated by earthquakes. Is it a way? It is a way, but, as we say, it's an indirect way. We estimate the core's properties by analysing other characteristics such as wave propagation speed, phase, amplitude, and several other attributes present in the earthquake-generated signal. But it would be great if we could access the Earth's core, at least have direct access to something. In the case of the mantle, we do. When a volcano erupts, we go and collect that molten rock. It comes from the core, from the Earth's mantle. So, it's a way to directly access what's happening in the Earth's mantle. But the core is very challenging. Fortunately for researchers, there are certain locations on Earth, one of them being in the Arctic, specifically in Canada, called Baffin Island. In this place, geochemists and folks in geology and geophysics related to chemistry study and have detected a leak. You know what? The famous HELIUM-3, the one I often talk about to you, that's right, HELIUM-3 is leaking. So here's the deal, right? Everyone hears me saying that there's no helium-3 on Earth. Why not? Because helium-3 forms when ultraviolet radiation interacts with lunar rocks, creating helium-3. Helium-3 indeed doesn't exist on the Earth's surface, but we have helium-3 in the Earth's core. What's the reason behind this? During the Earth's formation, the core formed, producing helium-3. Then came the mantle and covered it, followed by the crust, essentially trapping the helium-3 there. So yes, there is helium-3 in the Earth's core. But what's happening? In that island in the Canadian Arctic, helium-3 is leaking. How did researchers find this out? They went there and conducted field work. The researchers analysed rock outcrops, these rock exposures, conducting a complete rock description and geochemical analysis, discovering high concentrations of helium-3, something that cannot exist on the surface, due to what I've already explained to you. When helium-3 leaks from the core and reaches the surface, it quickly moves to the atmosphere. Helium-3 doesn't linger on Earth's surface. However, helium-3 is indeed present in the Earth's core, as I'm sure you've understood by now given my repetition. So, researchers discovered that in this region there's a leak, as if the Earth's core is seeping, releasing helium-3. This is fascinating for several reasons. First, by identifying this helium-3, we now have direct information. Remember what I said at the beginning? We can gain direct insight into the Earth's core because this helium-3 originates from there. So, this is invaluable in studying the Earth's core no longer indirectly but directly. So that's the first major discovery from this research, let's say. And the second, you might guess what I'm going to say next. Helium-3 is known to be the element that could make the nuclear fusion process run in the most stable way known. So could it be possible to take this leaked helium-3 from the core, which is currently leaking from the core, and use it to fuel nuclear fusion reactors? This way, for instance, in this scenario, we wouldn't even need to go to the moon because a small amount of helium-3 within the nuclear fusion process could generate a significant amount of energy. So, there's this question, why not attempt to use this leaking helium-3 from the Earth's core? Why? Because today we already have power plants. There are places in the world using geothermal energy as a power source, which is very interesting. There are places with volcanoes, geysers and more, but it's risky because when drilling they sometimes hit pockets of gas, causing explosions and many accidents in geothermal operations. Yet, people are already using geothermal energy, which is quite impressive. Could it be possible then to take this helium-3 and adapt it for use in nuclear fusion reactors? There lies this significant question about helium-3. So, you've understood and learned. Even though I mention that there's no helium-3 on Earth, it's more accurate to say it doesn't exist on the Earth's surface. The Earth's core holds a significant amount of helium-3, but it's trapped beyond our reach. Thanks to that point in Baffin Island, located in the Canadian Arctic, there's a helium-3 leak, The helium-3 is escaping from the core, reaching the surface, albeit briefly, then heading directly into the atmosphere. So, the big question is, could the leaked helium-3 from the Earth's core be used as raw material for nuclear fusion reactors to facilitate the most stable fusion process possible? Let's wait and see. So, that's the video I wanted to bring here to the channel for you all. I hope you enjoyed it. If you did, you know the drill. Don't forget the YouTubian package. Share, favourite, subscribe if you're not already, and leave in the comments what you'd like to know. Until the next video.